Welcome to another Algebra 2 podcast. In this podcast, we will be focusing on section 3.2. We will be solving systems of linear equations algebraically. For this section, we will be focusing on the elimination method. In order to use the elimination method, the equations must be lined up. That means that they must be in standard form. We have already learned about standard form this semester. Standard form means that the letters must be on the left side of the equation and that the constants must be on the right-hand side of the equation. You guys are already familiar with that. If your equations are not in standard form, then you know how to manipulate and you know how to put them into this specific form. The purpose of the elimination method is to get a variable to cancel out. If this does not automatically happen, then we will have to manipulate it so that it does. We may need to just change the signs of one of the equations, or we may need to multiply the top and the bottom by a constant. Again, the purpose of the elimination method is to get one of our variables to cancel out, and when this happens, we will have an equation with one letter that we know how to solve. Let's get started. We want to solve this system using the elimination method. Our system: 5x plus 2y equals 12, negative 6x minus 2y equals negative 14. The first thing I need you to look for in the elimination method, I need you to look at your letters, and I need you to decide if they cancel out. The 5x minus 6x, when we combine those like terms, they do not cancel. 2y minus 2y, those terms are opposites of each other. And remember, opposites of each other always cancel out. So this is the first type of problem that you are going to work with today. The variables automatically cancel. So when they do, we are going to combine our other terms. 5x minus 6x is negative 1x, and 12 minus 14 is negative 2. Here is the equation now that just has the letter x, and we need to get that letter x by itself. We need to divide both sides by negative 1 because there is an understood negative 1 in front of that x. So divide by negative 1 and x equals positive 2. Every system has two letters. So we're not finished. We cannot move on to the next problem until we find the x and the y for this system. And in order to do that, what you're going to do is to go back and pick one of your original equations. You can pick the top one or the bottom one, it doesn't matter, in order to find the second letter. I'm going to pick the top one here. And notice what happens. I have replaced in the top equation where the x was, I have put the 2 there, which is what we just found x to be, instead. We need to solve this system. We need to solve this equation. 5 times 2 is 10, plus 2y equals 12. We can get the y term by itself, so we're going to subtract the 10 on both sides. 2y equals 2. Divide both sides by 2, and y equals positive 1. We have already solved systems using the graphing method, and when we did that, we learned that a system has 3 possible solutions. We could have a system that intersects in one point, and we would have an ordered pair as our solution. We could have a system, our lines, that do not intersect, and we would have no solution, parallel lines. Or our system could be the same lines, one on top of each other, and we would have infinite solutions. When you are using the elimination method and you find a specific number for x and a specific number for y, then you know that this system, if we graphed it, these two lines would intersect in a point. Therefore, your answers to systems always need to be written as an ordered pair. Ordered pairs are always written in alphabetical order, so you never have to guess which letter comes first. So the solution to this system is 2, 1. That is the first type of problem that you are going to be working with when the letters automatically cancel. Let's look at the second type that you are going to have to deal with. We are still solving by the elimination method. Let's look at our system. Notice that those x's do not cancel out. They are not opposites of each other, nor do the y's cancel out. They are not opposites of each other. So right now, our letters, neither of our letters cancel out automatically. Take one more look at the x. If this is a positive x on top, if this were a negative x on the bottom, they would cancel out. So what we can do is, if we just need to make this x negative, we can do that, but we have to change all of the signs in that specific equation. So I have done that. Notice that I left the top equation exactly the same, but I have made the bottom x negative. And by doing that, I also had to make or change the signs of the rest of that equation. Now, x minus x cancel out, so we can combine our like terms. Negative 3y minus 2y is negative 5y, and 9 plus 1 is 10. Divide both sides by the negative 5, and the letter y is negative 2. We need to find the second letter. Remember, I said in order to find the second letter, it's always a very good idea to go back and pick an equation from your original system. Doesn't matter if it's the top one or the bottom one. I'm going to pick the top one again here. Notice that in the top one, instead of putting the letter y, I have substituted the negative 2 in place of the letter y. We need to multiply. This is a negative 3 times a negative 2, so we have x plus 6 equals 9. To get the letter x by itself, we need to subtract 6 on both sides, and x equals positive 3. We need to write this as an ordered pair, so the solution to our system is 3, negative 2. That is the second type of problem that you will have to work with when you can simply change all the signs in one equation in order to make your variables cancel. Now, sometimes there's not going to be a variable that cancels automatically, and changing those signs will not work. So what do we need to do then? The process that we're going to use is sometimes not the quickest, but it will always work. If your variables do not cancel and changing the signs will not work, then we are going to have to multiply the top and the bottom equation by a constant. So we're going to look at the coefficients in front of the letters and decide which numbers you would rather multiply by. It is a personal preference. Lots of people just tend to choose the smallest numbers. Okay. Now, I am always going to multiply by positive numbers, but again, it's not set in stone that you have to do that. You can multiply by negative numbers, but I try to steer clear of that, and I always just multiply by positive numbers. Here is the third type of system that you are going to have to work with today. Let's look at it. Notice that the x's do not cancel, the y's do not cancel, nor can I just change all of the signs in one of the equation and make them cancel. So we need to look at the numbers in front of x. There's a 2 and a 5. We need to look at the numbers in front of the y. There's a 3 and a negative 2, but I'm just going to say 3 and 2 because I'm not going to multiply by negative numbers. So do we like 2's and 5's, or do we like 3's and 2's? I would rather multiply by 3's and 2's. So we're going to take this 3 and we're going to have to put it on the bottom, and we're going to multiply that equation by 3. We're going to have this 2 and we're going to have to put it on the top, and we're going to multiply the whole top equation by 2. So it's going to look like this. Notice that I moved the 3 to the bottom and I took the 2 to the top, and I have parentheses around the original equations. I've got those parentheses there because we are going to have to use the distributive property. So our new system, 4x plus 6y equals 12, and 15x minus 6y equals 33. Here is our new system. And if you will look at your y terms, notice that positive 6y and negative 6y are opposites of each other. Those cancel out. So we can combine our like terms. 4x plus 15x is 19x, and 24 plus 33 is 57. Divide both sides by 19, and x equals positive 3. To find the second letter, always go back to one of your original equations. I'm going to pick the top one, and if you will notice, I have put a 3 in place of the letter x on the top. Multiply. 2 times 3 is 6, plus 3y equals 12. We need to get this 3y by itself, so we are going to have to subtract 6 on both sides. 3y equals 6. Divide by 3, and y equals positive 2. Our system, we need to write our solution as an ordered pair, so the solution to this system is 3, 2. Let's look at one more. Okay, here is a system. Notice, let's look at the x's. They don't cancel. The y's, they don't cancel. So, I'm going to look at the numbers in front of x, and there's a 3 and a 2 there. I'm going to look at the numbers in front of y, and yes, I know that's a negative 1 and a 5. I'm only going to say 1 and 5 for multiplication purposes. So do we like 2's and 3's, or do we like 1's and 5's? Personally, I like 1's and 5's. So I'm going to take the 1 is on the top. I'm going to put the 1 in front of the bottom equation. 5 is on the bottom. I'm going to put the 5 on the top of I'm going to put the 5 with the top equation. So now it's going to look like this. Let's distribute. 10x minus 5y equals 30. 3x plus 5y equals 22. Notice again, let's look at our y terms. They do cancel out. They are opposites of each other, so we can combine the rest of our like terms. 10x plus 3x is 13x, and 30 plus 22 is 52. Divide both sides by 13, and x equals positive 4. To find the second variable, pick one of your original equations, and again I'm going to pick the top, but remember it doesn't matter which one you pick. It's not a hard question to decide about, okay? Either one is going to give you the same answer. I've put the 4 in place of the x, so let's multiply. 8 minus y equals 6. We need to subtract 8 on both sides. It is positive, there's no sign in front. So now we have negative y equals negative 2. Divide both sides by negative 1, and y equals positive 2. Our answer needs to be written as an ordered pair, so the solution to this system is 4, 2. Okay. One more. Let's examine this system, and we want to solve it by the elimination method. Notice that your m's do not cancel, nor do your n's cancel, and we just can't change a sign. So, do we like 5's and 4's, or do we like 2's and 3's? I'm going to pick the 2's and the 3's. So we need to take the 2 and put it on the bottom, and we need to take the 3 and put it on the top. So it's going to look like this. Distribute. We get 15m plus 6n equals negative 24. 8m plus 3n equals plus 6n, I forgot to multiply, equals 4. Now, let's look, after we've distributed, here is our new system. Notice that the m's do not cancel out, nor do the n's cancel out. Those are not opposites of each other. So we need to use the concept that we have already talked about earlier in this lesson. This is a positive 6n on the top. If this was a negative 6n on the bottom, they would cancel out. So if I want to make this 6n negative, then I have to change all of the signs on the bottom. So here is what the system now looks like. The n's cancel out. Combine like terms. 15m minus 8m is 7m. Negative 24 minus 4 is negative 28. Divide both sides by 7, and m equals negative 4. To find the second letter, go back to one of your original equations. I'm going to pick the bottom one this time. Remember I said it doesn't matter, but I'm going to put the negative 4 in place of that m. So it looks like this. Let's multiply. 4 times negative 4 is negative 16 plus 3n equals 2. I need to add 16 to both sides. 3n equals 18. Divide by 3 and n equals 6. Our solution needs to be written as a set of ordered pair. Our solution needs to be written as an ordered pair. And remember, they are always written in alphabetical order. So the answer to our system is negative 4, 6. Let's look at this system. So far, all of our systems that we have worked in this lesson have had ordered pairs as solutions. Remember, there were 3 types. You could have an ordered pair, you could have no solution if they were parallel lines, or you could have infinite solutions if they were the same lines. So here is an example of the other type of problem, okay, our other types of answers. Notice that your 2x and your negative 2x, those cancel out automatically. And notice that the negative 3y and the positive 3y, they cancel out automatically. There are no x's, there are no y's on the left-hand side of this equation. Our variables cancel each other out. All of them are gone. So on the left-hand side, we have a 0, and on the right-hand side, 6 minus 6 is also 0. Now, when your variables cancel out, you will not have an ordered pair as an answer. You will either have no solution or you will have infinite solutions. When the letters cancel, that is the only time, when both of your letters cancel, that is the only time that you could get infinite solutions or no solution. Now, when the letters cancel, you have to decide if this right here makes a true statement or a false statement. Does 0 equal 0? Absolutely. So this is a true statement. Therefore, this system has infinite solutions. Because it's true, our system has infinite solutions. If we graph these, they would be the same lines. Now, if the statement right here had ended up being false, maybe it said 0 equals 5. Well, 0 would not equal 5. So if your statement happens to be false, then the system has no solutions. That means that our lines, when we graph them, would actually be parallel. They would have no point in common. This concludes the lesson for section 3.2, solving systems by elimination. And we have talked about 3 types. If the variables automatically cancel out, changing the sign to make a variable cancel out, or multiplying both equations by constants. I hope that this has been helpful, and more podcasts will be forthcoming.